Good morning, awesome pre-algebra students. This is lesson 9, and our objective for today are what are prime numbers and how can we use them? So what are prime numbers and how can we use them? And this is super exciting because we're talking about prime numbers, and prime numbers are one of those things that have fascinated mathematicians for a long time that we still can't fully explain. So something that's pretty cool. But first of all, I guess let's talk about what is a prime number. A prime number is a counting number. So pause real quick for a second. Remember, counting numbers are numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. On out from there. So prime numbers are counting numbers that's bigger than 1. So that means it can't be 1. It's got to be 2 or bigger. That has exactly 2. So not 3, not 5, not 1, but exactly 2 different counting numbers. So again, those same counting numbers as factors. So remember back to what factors are: 2 numbers multiplied to give you your number. The number itself and 1. So let's just real quick, let's think of a number 6. 6 is a counting number. If I took its factors, it'd be what? 1 times 2 times 3 times 6. Or 1 times 6 and 2 times 3 are all of its factors. Since I can come up with 4 different ones, it's not prime. If I can only come up with 2 of them, like maybe on your last quiz, remember I asked you to find the greatest common factor of 2 and 3, and it was 1 was actually its greatest common factor. It's because 2 and 3 are both prime numbers. So let's just maybe do one more. Think of a number, maybe 3. Find its factors. Well, it's just 1 and 3. Are those only factors? Since there's only 2, 3 and 1, then 3 is a prime number. Yay! Okay, so just a couple questions. First of all, is 1 a prime number? We kind of already answered that. No, 1 is not a prime number. A lot of people think it is, but don't be fooled. By definition, it has to be bigger than 1. Therefore, 1 cannot be a prime number. Next up, how many prime numbers are there? Well, actually, there has been a mathematical proof that's pretty long and extensive that says that there are infinitely many prime numbers. So just like there's infinitely many numbers, there's infinitely many prime numbers. So we'll never be able to find the biggest one. But if you want to find something interesting, just Google largest known prime and see what comes up. It is a huge number, and it's pretty awesome. Okay, and then I guess the last thing is there a formula for finding a prime number? Or like a test that we could do that says, here, I'm thinking of this number, 17. Is it a prime number? Yes or no? Can I put it in this formula? Well, the answer is no. There is no formula for prime numbers. There's no formula for prime numbers. There's not a way that they're evenly spaced or anything like that apart. So we have a really hard time finding prime numbers. You literally have to just take a number and try to divide it by every number smaller than that. Of course, we have smart techniques, so we don't have to do every single number, just to see if it's prime. And if one of those is a factor of it, then it's not. And in fact, there is a $1 million prize for anyone who can come up with a formula to find prime numbers. It's an amazing thing. And also, cool fact over here, if you haven't already read it already, the U.S. and everyone else depends on computers not being able to find prime numbers for security. So whenever we send out secure messages from one country to another, we do that using the fact that a computer cannot factor numbers very easily or very quickly. It takes it a really long time. And so the fact that we use numbers that are multiplied with really big prime numbers makes it impossible. Well, not impossible. They calculate it in like thousands of years for a computer to calculate what those prime numbers are. So it's a pretty cool, awesome thing, prime numbers. Okay, so let's see how we're going to use those. So remember, what we're about going to do is computers cannot do this. When you have a calculator that says whenever you divide by a number, whenever you like 12 divided by 4, a computer can't do that. It's not a program for it. It's just like rote memorization for a computer. It has, like factors of this are blah, 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 blah. So if you get a really big number that doesn't know, then it's time to try to refer back to it, blah, blah, blah. Anyway, so what you're doing in your mind, a computer cannot do. You're better than a computer. All right, and just up here in the top right, notice I've just written out some of the first few prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. Those are some prime numbers. So I guess the easiest way to find the prime factorization of a number, which is really just what prime numbers do I multiply together to get that number, is to use a factor tree. And that's why I drew this super awesome tree over here on the right, is just to remind you that you can use a factor tree. And a factor tree is just simply, you try to think of two numbers you can multiply together to get you that number. Well, I always kind of start with 2 and something, because I'm thinking like half of it, especially when it's an even number like this. What's half of 52? Well, half of 50 is 25, so one more than that, 26. So 2 times 26, you give me that, and I'm going to circle any of them that come out to be prime. And 2, notice, appears prime. So I'm going to use that. 26, let's see. Which numbers multiply to give me 26? Since it's still even, I'm going to go with 2, prime number, and 2 times what? 13 gives me 26. 2 times 13. And look at that, 13 is also a prime number, so there, I'm done. 52 in its prime factorization would be 2 times 2 times 13. Or if you wanted to, you could say 2 squared times 13, but I think that might be a little bit above you. But anyways, there you go. 84, so I'm just trying to think of two numbers that multiply together to give me 84. Well, I'm thinking of 2 and 42. Because again, that's half of it. 2 is prime, so I'm going to circle it. Which number's there? Again, even, so 2 times 21. 2 is prime, 21's not. 3 times 7. 3 is prime number up there, and so 7. Da-da-da. Alright, and if you notice here, my trees are kind of lopsided, but if this kept branching out, maybe over here and over here and over here, it'd kind of look more like a tree like that. Except for maybe not quite as awesome. Alright, so there's the basic idea of how to find the prime factorization, which means the prime numbers you multiply together to get that number. Okay? Now, basic terminology here for the next thing is a composite number. A composite number has more than 2 counting number factors. So remember, prime numbers have exactly 2. And so if it has more than 2, then we call it a composite number. A composite number. So something like 6 is a composite number because it has more than 2 factors. Okay? I think that should get you well on your way with this. Remember, you're working with something that is super awesome right now. Computers cannot do what you are doing. So just remember that. Good luck on your homework. It starts on page 57. When you do all of them from this lesson, 9. Just a reminder, all of them from 8 as well, and then 11 more of your choice. Good luck, you awesome students.